Well, welcome. Good afternoon. We opened up the conference on the first day with an introduction to the Smart API, and I shared some background about this app platform where third-party applications can connect to an electronic health record system and to other health data platforms and access what is often a core set of clinical data. Sometimes we think of that as a set of clinical summary data. In the US, we've got national profiles around this that spell out how to share things like medication lists and allergies and problems and vital signs. But very quickly, we start to see other domains of data that are not commonly available through these EHR endpoints. Oftentimes, under the hood, these kinds of data are stored in totally different software systems. And for some reasons that are very good, separation of concerns, also some reasons that are historical, just development of systems over time. But if you're a clinician or if you're a patient trying to access the full picture of health data, these kinds of separations can be quite artificial. They can get in the way. So I want to talk today about a project that we have underway to expand our core set of patterns for providing access to data that goes beyond just what's stored in an EHR, but still leverages the parts that have been built around the EHR infrastructure. A little bit of housekeeping. There's a link at the top of this slide to bit.ly/smart-fire-tech. So you'll find this slide deck and others at that location. And a quick call out to the Dev Days feedback site. I will share the QR code and another reminder at the end of this session. But I really would love feedback and suggestions for how we can make this a better introduction and a better talk over time. So please do be thinking about this. And also, I think we've got a small enough crowd that if questions come up during the talk, if I say something that doesn't make sense or there's another area you want to explore, please just raise your hand. I'll try to keep an eye out on the audience. If for some reason I miss you, just shout out. It's one of the nice things about being able to do this as a hybrid event with some folks here in person. And we'll save time for questions at the end as well. Okay, let's dive in. One way that I could really share this problem statement is that over time, our computers have been getting smaller and smaller, to the point where we can fit them in our pocket and carry them around with us all day long. But CD-ROMs have stayed exactly the same size. So you just really can't fit a CD into your phone. And so this is a problem if the only way you're getting access to your imaging data is on a CD-ROM. And that is still really a very common situation, at least in the US, where patients in particular who might need to access their data to be able to have an archival copy or bring it to a specialist visit. Patients are often sent down to the basement of the hospital and they get the imaging put onto a CD for them so they can take it away. So that's a real challenge. You just can't read those CDs on a lot of contemporary devices. And also for patients as well as clinicians, imaging is really just one modality of data. But if we think about making the right healthcare decisions, figuring out the right diagnosis, looking through treatment options and selecting the best one, understanding the trade-offs, calculating risk scores so you can figure out what's likely to happen to a patient. All of those things work better with access to a broader set of data. So just because the technical systems are partitioned in these various kinds of networks doesn't mean that the clinical logic ought to be. So I'm going to share with you a pitch for this project, this imaging access project, that we made in the Argonaut Standards Accelerator earlier this year as kind of an anchor point. This is one of the projects that we selected to work on in 2023, and that work is underway. So I'll also share links to our draft specifications, to our reference implementations. We certainly would encourage early participation and feedback. We're at kind of a neat stage in the project right now. But I'll admit, I made a pitch like this a few times in the past, and we never quite got traction on it. We were able to lay some of the groundwork over the years, and I'll highlight those aspects as we go through today's talk. But this year, we got buy-in to trying to produce some specifications that solve this problem end to end. So what problem am I talking about? The format of these next couple slides are something we used internally through the Argonaut pitch process, because we'd thought about probably 24 different projects that we were considering taking on, and we needed some way to narrow that down to a final set of maybe 3 to 5 that we could actually tackle. So we try to have a pretty concise pitch process. What problem are we solving and for whom? And the quick problem statement, which is a little bit technically oriented, is we want to solve the problem of giving smart apps access to imaging studies right alongside clinical data, using the same authorization flows that they're already following in order to get that access. So that's a technical problem statement. But in terms of real users trying to do real stuff, there's a lot here. So for healthcare providers, you might just think there's a lot of different imaging tools out there for making sense of DICOM studies, CTs, MRs, and oftentimes you might want a viewer that is specific to the clinical problem at hand. You also want to be able to calculate risk scores using things like automated algorithms. You might want to be able to automatically segment and derive some predictions based on the data in imaging. Or you might just be sending a patient for a consultation, and you want to make sure that the external consultant, the specialist that they're going to be seeing, will have all the information they need. So you want to make sure imaging data is flowing right along with the patient. So those are all things that might make sense from a clinical workflow perspective. Or for patients who might be accessing their own images, there's a lot here too. One might just be sort of the impulse to keep an archival copy of your whole health record. You never know what's going to happen in the future. The healthcare system can be fragmented. You might be traveling to a place that's not well connected with the home care system where you might have received these images or studies. So for patients, it can be useful just to have everything in one place under their own control. But this can also be a way for patients to understand and engage in their own health. Images are quite tangible, and even if they just want to sort of look at and get a better sense of what's happening inside of their own body, this is a data modality that can help. But quite frankly, there's also a lot of places where patients are filling in gaps in our clinical workflows. So as a patient, you might want to make sure you can get a second opinion and send along your images with that second opinion, even if your primary doctor is not really aware that you're going out for that second opinion. Maybe you don't want to tell them. Maybe it would feel awkward. And so having, as a patient, a way for you to access and share your information as you see fit is really important. And then one of the motivations that actually spurred the original funding for this project, going all the way back to 2017, was helping patients who might want to donate their data for research. And oftentimes patients might want to do this out of motivation from their own personal health history, or a family member who might have a disease and they want to do what they can to help the scientific community understand these disease states and treatments and interventions better. So there's many different reasons why applications might want to help users work with imaging data. I'm trying not to pick any favorites here, but just to sort of paint a picture that there's a lot that's possible. And just to be a little bit more technical on the clinician-facing side, there's a lot of work happening right now at the sort of research level to understand how to make better automated predictions based on imaging data. But this work is not widely or evenly distributed across the field. So there might be some academic centers that have gone really far in developing their own algorithms for calculating kidney volume, and others who have been focused on automated measures of heart MRIs. And by making imaging data available through the same pipelines as clinical data, we allow these connections to flow. We can start running these calculations, even if the group that built them is not deeply connected with the site where the images were taken. On the patient side, I include this example, even though it's a little bit frivolous, because I think it's really important. We just want to let people do whatever it is they want to do with their data. I've talked to many people who were excited to participate in brain research studies because they knew at the end they would get a DICOM file with their brain in it, and they could go and make a 3D print of their own brain and have that as a decoration for their living room. Or maybe you just want to order a set of coasters for your table with slices of a brain CT. And I think a lot of folks sort of look at these use cases and think, it's trivial, it's a gimmick, but the truth is these are just more ways for people to engage with their own health information and understand it, whether it's just out of interest, out of an artistic impulse, or a learning exercise. And for me, these are all equally good. We should be defining APIs that make all of these things equally possible so that end users can decide what apps they prefer and what jobs they want to do. So in the US context, at least, one thing that comes up very quickly when we start talking about these use cases is, well, we've already got these networks. They're really good at connecting different health systems together. Everybody signs on to a common trust agreement, and then people can broadcast queries from one hospital to the next. And those networks have been moving CDA documents around for a long time. There's specifications that would allow those networks to move around imaging files, DICOM and the like. Maybe that could be the basis of imaging access for apps. And my take, at least, is that this is not quite the right fit for the problem at hand. Those specifications are all about getting data from one organization to another. But frankly, what we want to be able to do is, in near real time, hook an app up to the local set of data that's available within an institution. whether that's a patient accessing their own health records or a clinician pulling up a patient chart in the EHR and looking to make sense of the various aspects of their records. So oftentimes these networks are routing data in kind of a slow or back-end fashion. And even when it works, patients can't figure out that's what's happening. Patients can't tell if their data are being shared, and it's very possible for things to fall through the cracks. I think it's very important, even as just a complement to these kinds of network-based exchange models, to make sure we can surface the data that live locally within an organization. And one of the things that we look for in the Argonaut project each year as we're selecting what to work on is, do we have an existing specification? Is there a starting point that we can use to build on? Or would we be essentially starting a new design project from scratch and trying to understand use cases and the technology options? And in this case, we did have a starting point. It was the project that I mentioned from back in 2017, where we had some US federal government funding to work on this use case about data donation for research. So that project was called Sync for Science, like synchronizing your data on behalf of some kind of scientific research project. And essentially what we laid out in that project was a specification that used Smart on FHIR and used DICOM Web services in a consistent way to allow apps to be able to fetch clinical data and imaging data side by side. So we built on the smart OAuth authorization flow that we talked through here at Dev Days on Tuesday. And we thought this would be at least the right starting point for discussions of further development. Last piece of the Argonaut pitch was really, what does a successful outcome look like? And we tried to scope this pretty narrowly. We said, for a successful project this year, kind of 2023 calendar goals, we'd want to make sure we had participation from EHR developers, from organizations that today manage and host imaging data, often inside of PACS systems, picture archiving systems, and that we'd want to have participation from clinical providers who thought that this kind of functionality was important to turn on within their own organization. And a successful project then with those participants would be working through a basic specification, making sure that we've got reference implementations that are capable of serving in the server role and the client role so that we could try this all out, having some kind of self-contained demo that we could show, and then having some path to be able to evaluate this inside of a real clinical provider organization. And one thing that we've done in Argonaut, which is a little bit different from how standards development often plays out in the HL7 world, is we really try to work through these specifications in kind of a community setting, test them out and make sure that we're happy with them before we bring them into the formal balloting process, which is HL7's kind of pipeline for bringing a formalized consensus around these specifications. So we do our work out in the open. The calls are open for anyone to join. The minutes are all publicly posted, but we're not trying to achieve a formal degree of consensus yet. We want to make sure we've got something that we're at least comfortable with before we move on to that step. All right, so let me start by giving you a quick demo and tour through the draft specifications that we've got. Before I dive in there, let me just pause and see if there's questions about the setup or the use cases or the current lay of the land. Okay, so here's a quick demo. We'll see how the Wi-Fi wants to play along here. The basic concept is this is an application that connects through Smart on FHIR to an EHR that has clinical data and imaging data available side by side. There might be different FHIR endpoints where those two things are available, but it's the same authorization flow and the app can just talk to each. And we want this simple app to be kind of a common piece of testing infrastructure so that as different participants in this Argonaut project start bringing servers online, we can test against their servers with one common app. So you can configure this app with a whole bunch of different servers that it knows about. You can tell it, for example, here's where the Cerner EHR sandbox lives, and here's where the Epic EHR sandbox lives, and here's where the Smart sandbox lives. You can come in here and configure it to talk to any Smart on FHIR endpoint that you want. And just to start off the demo, I will show you this app connecting to our own Smart on FHIR sandbox, which launches an authorization flow, or might, depending on how the Wi-Fi wants to play around. And in this authorization flow, typically a patient would sign in. They would be given some kind of prompt asking whether they in fact want to share their data with the application. And I'm going to approve it here. I'm sent straight back to the app after granting access. And the app is able to run a bunch of queries that are populating these two little cards along the left-hand side of the screen. So first of all, the app is querying the EHR's clinical FHIR endpoint for a bunch of things. it's asking for patient demographics, so it gets the patient resource to be able to display name and birth date. And then it's issuing just calls for this patient's allergies, active medical conditions, and active prescriptions. And it's just doing that to show, like, sure, we can write some FHIR API calls for the usual stuff. And then the interesting part for this demo is the box below this, which is a list of imaging studies. So it has done a FHIR API call. We'll look at the details in a moment. And it's gotten a list of 4 studies that are available for the current patient in context, Danae, who's one of our Cynthia-generated sample patients. And so here I'm going to say, I'm going to pull up this upper extremity study. And what happens when I click that button is that the full DICOM study is loaded from the backend server where it's stored into my web browser. I'm not doing anything fancy to select certain slices. I'm not doing anything fancy to ask the server to render the images for me. I'm just bringing the entire binary payload into my browser and then using client-side libraries to parse out those data and draw the pixels to the screen. I point that out because there's often a debate here. There are some trade-offs to make when working with imaging data that can be quite large. And how much do you want to bring to the client if all I need is sort of a quick glance at this image versus how much could I lean on the server to maybe just render this preview for me, and I don't need to spend so much bandwidth or time transferring. And so we've put together some guidance to try to address those trade-offs. But the number one capability that we want to make sure is enabled here is access to the full strength imaging files. And so I've used that as the basis for this demo, because even if that's all a server does, I want to make sure that we can show that working in the browser. So within this context, I've already loaded all the images associated with this wrist X-ray, and I can flip between them just using a browser-based library called Cornerstone, which is quite an amazing artifact for working with DICOM images. It makes it quite simple to just draw onto a canvas in the browser, load some raw DICOM binary files into the context, and if I pick a more interesting kind of study, like we'll see if this brain MR wants to load, I can show you, it also lets you do things like moving through the slices of the image. Pretty basic stuff that any DICOM viewer would do, but it's just a few lines of JavaScript to be able to plug those pieces together, which is really fun to see. So what's happening under the hood here? I want to give you a few different views on the underlying API. So the first thing I'll show you is just sort of bottom up, what actual calls are happening from my browser to the server in order to make this demo come together. And then we'll talk through the specification itself. First thing that happens is when I selected that smart sandbox to connect to, the browser went and did a smart configuration API call. So if you know the FHIR server endpoint, you just add .well-known/smart configuration, and that gives you things like, where does the EHR's authorization server live? And where does the EHR's token endpoint live? So once we get that, we can launch into an authorization flow. Let me actually reload this page once more, because I realize I have a background tab where the demo I just showed was connecting, and it skipped the authorization step. So let's just prove that once more so we can see each of the steps in turn. So in our network tab, we do that discovery call. We make an authorization request. So that's not actually what's called a fetch. We're actually redirecting the user to the authorize endpoint in order for them to hit the approve button. So to see that in the list here, I'll have to go into sort of the full set of requests, and we can see we called the authorize endpoint, just standard smart launch, and we passed in standard parameters like our redirect URL, our response code, our response type, client ID, and so forth. Totally standard smart on FHIR launch stuff. Once the launch is approved, the app is able to request an access token. Again, totally standard smart on FHIR workflow. It posts the authorization code to the token endpoint, and it gets back this nice access token response. So it's got the access token itself, which we'll use in making subsequent requests. It's got an expiration time that tells us this is going to be good for an hour. And it has a set of scopes, which in this case tells us this access token is good for querying any kind of data associated with the patient in context. By the way, who is the patient in context? Well, it's this patient ID here. And that's everything the app needs to now proceed to issue some API calls. So first thing it does is it fetches this patient ID using a FHIR read, and it gets the basic demographics that we were looking at on the screen. So for example, the patient's birth date that we were looking at a moment ago, this is what we rendered onto the screen. And we fetch allergies and conditions and medications about the patient, all totally standard stuff. And now we come and we request imaging studies. So what's going on here? We're not actually talking to the EHR at this point. We are talking to an imaging server. This is where we're going to go to ask what imaging studies are available for this patient. But otherwise, it looks like a pretty standard FHIR API call. We're passing in 2 parameters, or just actually 1 parameter, which is the patient. Tell me all imaging studies you know about this patient ID. And we get back a FHIR search bundle. In this case, these are the 4 studies that we saw drawn on the left-hand side of the UI. Each one of these things is a FHIR imaging study resource. So we'll see that resource type. There's details about when the study was done. There's a standard DICOM identifier for this study, which serves as a unique, globally unique ID for it across any different system this study might be loaded into or transferred across. And then some detail like this is a study with 7 series and 124 instances. So those are kind of the slice level details that we saw earlier. And most importantly, there is what's called an endpoint. And this tells us, okay, let's say I want to get the pixel data for this particular left knee study. Well, what kind of study was it? It was a modality of MR, which is a magnetic resonance study, and also doc, which means it's going to have some kind of clinical documentation as well. It's kind of a funny example, but this is a pretty common thing to just take a snapshot, a picture of a note, and include that alongside the other images. It's sort of like if you have a hammer, everything looks like a nail. So if you're sending along DICOM studies with MR imaging data, why not throw a note in as well? I didn't show that in the demo earlier. Let me hit the load button and see if I can actually get that to come up. But meanwhile, the endpoint. So if I actually click on this knee MRI and I want to see the data, I'm going to follow this endpoint link. And that's going to tell me a very specific address I can go to fetch the details for this study. And the contract that the app has is, if it knows this endpoint address, it can issue a smart access protected read on this endpoint, and it just puts in the image study that it wants to retrieve. So it uses this ID as a parameter, and that's exactly what's happening here when we fetch the study itself. So what's going on here? We make a request to that endpoint that I showed you, and we append /studies/1.3.6, and so on. That is the DICOM Web API call. It says, given this endpoint, I want to fetch a particular study. And there's many levels of data you can fetch in DICOM Web, but the simplest thing you can do is fetch the whole study. So what happens here is you can see we're getting some binary data over the wire. This is using MIME multipart. The DICOM standard defines exactly how this stuff works, but you get this little separator here, which is kind of a random number. And we're sharing like 130 files in this payload. Those are the 130 slices that we learned about in the FHIR imaging study resource. So we're expecting to get a whole bunch of these files. Each one is going to be some binary data. You can see when you render it as ASCII on the screen, there's some human readable text in there. There's some plain old ASCII stuff. I think that's the study identifier, and then a whole bunch of actual binary pixel data. But if I scroll through this long file, you'll see that separator is going to appear like 120 times. Got upside down 10 minutes left. Hopefully that still counts as regular 10 minutes. Yeah, cool. We're doing good. You fetch this whole file. How big is it? It's actually 78 or 76 megabytes. So non-trivial. This might not be the kind of thing you want to stream to a user's phone on a slow connection every day. But at this stage, the goal is just to say, even with a very small API, we can enable this kind of access. Okay, so that's the demo. I mentioned that sometimes there's notes just sort of stashed away alongside the images. So this was an example of what that might look like in a DICOM viewer. And this is anonymized data. So you see redacted information here. Some of this has been whited out. All right, I want to talk about the spec and some of the reference implementations. Let me just see if there's questions before we dive into that, either about the demo or about notes that I've made so far. People following along, does this sort of make sense so far? Okay, cool. So there's a few concepts that we introduced so far, that are sort of in this cluster around smart imaging access. So hopefully you have these in your head already, but just to sort of drive the point home, there's some things that have to do with the app workflow. So the app is always going to have to get authorized. It's always going to do some FHIR queries to get clinical data, to get imaging data. And then if it's interested in specific imaging studies, it's going to go and retrieve those studies. But it only needs to retrieve the studies that it wants to retrieve. So the only large payloads we're talking about are sort of down this branch. Everything else is pretty small, pretty fast. Okay, we're talking about two different sort of data subsystems. One is what I'll call the Smart on FHIR EHR, which is hosting the clinical endpoints, but it's also hosting the authorization endpoint. It's gathering the end user's permission about what access to delegate to the app. And the imaging subsystem is going to follow along with those authorization decisions. So it doesn't have its own authorization layer for deciding who can access what. It's deferring to the access tokens that come from the EHR. And that's part of the sort of glue and magic that makes this technique work on the basis of this smart enabled EHR system. So I won't go through the spec top to bottom, but I will just sort of show you that there's not too much to it. The imaging asset specification itself talks a little bit about some of the assumptions we make, like there's a Smart on FHIR EHR, and it's going to be sitting next to an imaging data subsystem. There's some considerations about how we scale this in the real world. So like, how does this imaging system support FHIR? What if under the hood, all this health system has is a traditional DICOM PAC server or a DICOM Web endpoint? How do we make sure these data can be available in FHIR when the app comes by to query them? How can we support those kinds of workflows? And then the basic steps that an app is going to follow. It can call the EHR endpoint and say, hey, do you have any imaging servers? If so, where do they live? Like, can you do imaging or point me to somebody who can? There's the authorization flow, and then there's queries for fetching the actual imaging data. I want to make just a few notes about those queries for fetching the imaging data. First thing to say here is we try to keep them very constrained. So the FHIR API has all kinds of search capabilities, many different search parameters for imaging studies, and we pick out a very small number to be required for support in this implementation guide. The core use case is I've got a patient in context, and I want to find the images associated with that patient. And if you return me like 30 imaging study resources instead of 2, it's not too big a deal. It's a small data set either way. But we have a couple of parameters that we can use to filter this down. Of course, we're passing in the patient whose data we want to fetch. So we're only going to be focused on study for that patient. Of course, we need to know the endpoints where the data can be fetched. So you've got to be able to support including endpoints in your response. Otherwise, the apps will hit a dead end. They won't be able to follow that link to the image. And you should be able to filter by date. So if an app wants to keep in sync with the latest stuff, there should be a way for the app to just say, tell me the stuff that's changed since the time of my last query. So that's the last updated parameter. And beyond that, we don't say anything. So servers are welcome to support more search parameters, but that's the basic set that we start from. The other interesting aspect here is timing. So in the demos I showed you, the app issued a query, and it got a response right away, synchronously, milliseconds. In some real-world deployments, that might not be possible. Maybe you want to build a proxy that doesn't store any data, and under the hood, all it can do is write what's called a DICOM DIMSI query using this TCP connection to different underlying imaging servers. Well, in that case, you might not be able to get a synchronous response. So our profile says, if you don't have the data right away, if you know you need some time to be able to fetch it from the different places where it lives under the hood, you can respond to the app with a status code, an HTTP status that says, I'm not ready yet, and I need a little bit more time. That is what's called the 503 status and a retry after header. So you're saying, I can't respond right now, but here's how long I need before you should try that query again. And I think a lot of real-world implementations won't need this level of flexibility, but we thought it was important to build into the spec because in some deployments, that's just going to be the fact of life. And we don't want to shut ourselves down from being able to support that kind of infrastructure. So the endpoint can respond with that for the search that tries to get a list of studies. And the same exact thing is possible when the app tries to retrieve a specific study. So the app might say, OK, I want to get study 1.2.3, and the server can respond with a 503 there as well. And that's the basics of the API. We tried to build it on top of what already exists in Smart on FHIR and what already exists in DICOM Web. So it's a very short specification. It'll probably grow a little bit as we learn some of the bugs and iron these out in this year's Argonaut project. But that's kind of what we're working with. Under the hood, for this server to do the right thing, I mentioned that it needs to enforce access control decisions that come from the EHR. And I want to spend just a minute talking about how that happens. Now, this might purely be an implementation detail. Maybe a health system is writing its own EHR and its own imaging server, and they just talk to each other and they share authorization information. That's fine, but we want to make sure there's a more flexible and more loosely coupled option. And so what we define is in the core Smart on FHIR specification, we have a capability called token introspection. And this is part of what's required in the US for all certified EHRs is if you're issuing access tokens, you also need to allow clients to come by and say, hey, I found this access token. Somebody gave it to me. What's it good for? What patient is it good for? How long is it good? What scopes does it have? That's what's called the token introspection API. And so you could see if you have this API available, you could start to build a proxy that receives a request from a patient app or a clinician app. That request comes with an access token. And you as the proxy, you say, well, am I going to let this request through? Let me perform token introspection. I'll see what this token is good for. And so you talk to the EHR, you give it the token, and the EHR says, yep, that's an active token. It's good for reading all data on patient 456. So as the proxy, now you know that. But you see that the request is trying to read imaging studies on patient 123. And you say, well, no, I'm going to reject the request. Or if everything lines up, you say, very well, I'm going to allow that request to proceed. So that is one standard way that these kinds of proxy architectures can leverage the data that's coming from the EHR in order to make access control decisions when an app comes by and asks to get a list of studies or to retrieve the data in a particular study. All right, last piece that I want to just orient you to is a reference implementation. So this is something that I put together in order to have a server we could test with and a client that we could test with. So you've already seen the client. That was the web application that I showed. The server is kind of interesting because I tried to put together something that would be quite flexible. So it comes with its own little sandbox environment. It's actually just running a copy of the open source Orthanc DICOM server under the hood or internally. And then it has a little FHIR proxy that runs on top of that. So it makes DICOM web calls and translates as needed. And that's all pretty standard stuff. But I also wanted a way to show how apps could connect not just to my own sandbox, not just to the internal stuff, but also kick the tires on some of the EHR sandboxes that we talked about on Tuesday, things like Epic or Cerner's EHR sandbox. And in theory, when you're running an app like this, you should be able to point it to the Epic sandbox and authorize it using one of the Epic sandbox patient accounts. And as long as I grant it the right kind of access, it'll come back and now it'll be able to query the quote unquote Epic sandbox imaging server. And there's one where there's these two studies available. So how do I make my proxy this flexible? I gave it kind of a configuration language so that it can be configured to act like an imaging proxy in front of the Smart sandbox or the Epic sandbox or the Cerner sandbox and so on. Basically, just when you start it, it has a directory full of config files that tell it exactly how to behave. So the simplest one is called open. And so if you want this to just act as a totally open FHIR imaging server with no access control at all, you just put the word open in the URL. So I'd say imaging.argo.run/open/FHIR/imaging study. I'd do something like that. And when I do that, when I put the word open in the URL, it's going to behave like this. It's going to disable authorization, and it's going to just return all the images from the underlying Orthanc server. So that's a very, very simple configuration. Or let's say I want to make it work with the Epic sandbox. Well, this is a more realistic configuration. It's not going to be open anymore. Now it's going to use a Smart on FHIR authorization type. And I will say there's still a couple of aspects of the Epic sandbox that don't quite follow the spec. So actually, I call this Smart on FHIR with some bug fixes. But this is the point of a project like this, is you identify the bugs, and then over the course of the project, we can start shaving them off. So we tell it what type of authorization to do. We tell it the base URL. So this is the Epic FHIR sandbox base URL. We tell it a client ID. So I pre-registered a client as a developer with Epic. So they have an open website where anybody can come and register clients. And so I did that. I registered a client for my imaging proxy and another client for my imaging web UI. And so I just tell my proxy server, hey, when you're working with the Epic endpoint here, you should use this client ID and you should use this private key. Now, you'll notice this is not actually private because it's sitting here in a public GitHub repository. But this is one of the nice things about demo implementations and reference architectures. You can just put stuff out there so people can kick the tires and see how it works. And so my web server just reads this config file on the fly, and it uses this key to authenticate to this Epic endpoint, following the Smart on FHIR standard approach. And that allows it to serve as a basis for imaging access, even without folks on the other side having to do the heavy lifting to turn this functionality on. So there are some hard problems here, right? One of these is patient identity matching. So in the Epic Sandbox example, Epic hosts a patient resource. We got a sample patient that we loaded from Epic, and that patient has several identifiers in the FHIR patient.identifiers array. Now, our imaging server might know the patient by just one of those identifiers. So when a query comes in, it says, get me the data about patient 123. How do I find the right studies from my PAC system? So part of the configuration here is to try to answer that question as well. So I say, well, I'm going to query a certain identifier. I'm going to look up the patient in the Epic Sandbox. I'll fetch the patient resource, and I'll look through their identifiers, and I'll find the one where this identifier system is used, because maybe this is the one that my PACS knows about. And that's what's going to be used internally when I query the imaging server. I'll make my query based on that patient identifier versus another one. Now, the real world can get much more complex than this. Maybe you need to do your matching based on demographics. Maybe there's a probabilistic element to it. But I wanted to include at least enough of this complexity in my proxy to get a feeling for sort of what were the easy parts and what were the hard parts here. So that's a quick introduction to the Smart on FHIR Imaging Access API. Hopefully, you've got a sense of the intended user experience and at least roughly how the spec works. Want to leave you with the feedback URL for the Dev Days feedback page and open up for questions or comments or any other discussion folks might have here in the audience or on Whova.
Hey, thanks for the presentation, really good. So I had a small question regarding when the DICOM data is not available, and you said then we will issue a 503, which is kind of normally an error. And in FHIR, there is this async request pattern. So why not use that kind of saying, call me back here, but with a success code rather than an error code?
Yeah, so the question is, why not use the FHIR asynchronous request pattern? I think it's something we could look at. I mean, frankly, the asynchronous request pattern was introduced. Well, there's two flavors of the pattern. The one that we would need here was introduced in R5, and we've been really focused on R4-based implementations for our demos. That's partial answer. The other one is we wanted to keep the simple case simple. So we might change this over time. I don't think we're super committed to one approach or the other, but this was just the easiest thing to document.
Okay.
Other questions or comments?
If not, I have two questions on Whova. One question by Tim Dean. What kind of configuration and or support needs to be provided by the PACS vendor or imaging server?
So in terms of configuration from the PACS vendor or the imaging server, there's a couple of different ways to split the responsibilities here. And we try to be agnostic about this while also being thoughtful about what could work in the real world. So from an app developer's perspective, to make all this work, you need a Smart on FHIR OAuth server that you can connect to. And then underneath the umbrella of that authorization, you need a clinical endpoint you can connect to and an imaging endpoint you can connect to. So that's kind of the contract. How that contract is implemented is, from the app developer's perspective, an implementation detail, but from a health systems perspective, this is really important. What vendors do I need on board? What products am I buying? Who's paying for it? How difficult is it to wire everything together? So there's one story here where the PACS system might sit next to the EHR, and the EHR offers these top two pieces, and the PACS system offers the bottom piece. And in that case, the PACS system would need to be able to support the FHIR query and the DICOM Web fetch. You might instead have a proxy playing this role. And the proxy could be talking to the PAX system under the hood using whatever protocol that the PAX wanted to use. And in that case, the PAX doesn't need to know or do anything special because that logic or that extra work or translation is all living in your imaging proxy. There's a variant of that architecture in which the EHR plays the role of that imaging proxy. So under the hood, the EHR might be talking to various PAX systems, but the EHR might be the one hosting the FHIR search endpoint and passing along the DICOM queries, through in some streaming fashion. And so the core responsibilities are being able to support the API, but the PAX vendor might or might not have to do the work depending on how the pieces are put together. And apps definitely shouldn't have to care.
Okay, great. One more question from Ryan Harrison. What backend are you using for the FHIR authorization server in terms of scope consent, storage of scopes by user tokens, etc.? Is it Keycloak or Dunate?
So in terms of the components that we've built for this project, it's out of scope. We connect to some existing Smart on FHIR server, and it manages user sign-in, it manages access token generation, it manages scopes, and so on. So that's sort of the non-answer. Of course, we do have an end-to-end open source stack here. So one of the things that we support in the configurations of our proxy, right alongside the Epic sandbox and the open endpoint, we also have one that points to a smart sandbox. And so in this particular case, when we're connecting to the smart sandbox backend, it's using the smart launcher, which we talked about in Tuesday's session at launch.smarthealthit.org. And this is essentially a placeholder implementation. It signs you in no matter what password you type into the password box, and it is stateless. So it just puts all of its information inside of signed access tokens that it generates. So that's a nice set of implementation choices for a demo, not a real world set of implementation choices. As the question points out, there are good, high quality, open source choices for those components. And things like Keycloak are great in the open source space. There's also commercial products in that domain, which could be like Auth0 or Azure Identity or others.
Okay, thank you. Any other questions? No, if there are none, thank you for joining us today. And thank you, Josh. Great presentation.
Thanks.
Have a good day, everyone.